Hi, I'm Justin Snedden from the AR team at Niantic, and today I'm going to walk you through how to use semantic textures. So we did a tutorial earlier which showed you how to query the semantic buffer for things on the screen, like tell me if this pixel is the grass or sky or ground, that sort of thing. What we're going to do today is how to take that buffer and turn it into a texture that you can use as a mask. So as usual, I've assumed that you've already set up your scene. It can run on device and you're ready to go. If you haven't done that, please go and watch the Getting Started tutorial or look at the docs on how to set up a environment with the ARDK in it to run. So let's get going. As usual, we'll make a folder. We'll call this Semantics Textures. And in here, we'll make a new scene. Scene. Yep. And we'll just call this semantic textures as well. I think I called it semantics, so I'll be consistent. There we go. Just open that. And in here, let's do what we always do, which is we go to the camera and we get rid of the skybox. We say that we want a solid color and that we want this to be black. Then we're going to need to add in some managers. As always, I'm just going to put them on the camera. They don't have to be, but it makes it easier to demonstrate. So the first thing we're going to need is the AR Session Manager, because this will do all the things to turn on AR. We will also need a Rendering Manager and a Camera Position Helper. So Camera Position Helper and a Rendering Manager. So something to make sure that our device is in the right place according to Unity, and something to actually do some rendering. Now that we have those, then the next thing we will also need is, because this is going to be about semantic segmentation, we'll need to add the Semantic Segmentation Manager. So AR Semantic Segmentation Manager. As usual, just check that the camera has been set here. It's usually the script that it's not set on, but you can quickly eyeball the others just in case there is anything that might be missing. All right, so let's just save this scene. If we run it, obviously we're just going to get an empty scene because we haven't got anything happening here, but there's no errors, which is good, which means we can keep going. The first thing we will need is a script, and that script will be similar to what we did for the depth tutorial, where we're just going to have a callback in it to say, hey, whenever there's a semantic buffer, please give me that as a texture. So let's make our C# script, and we'll just call this semantic textures. Textures doesn't really matter. You can call it something else if you would like. Let's open that script up. And in here, we're going to add in a reference to the Semantic Segmentation Manager so that we can pass it in. So just a public variable to say, I need to use this manager. And in that manager, we're going to ask it to call our callback function. So in here, you can say, I want to hook the buffer updated command and tell it to call our own function that we will write in this script. So we just define that function as well. There we go. And we'll need a bunch of ARDK namespaces for this to work. So I'll also put those in here while we're at it. So the first one is the ARDK itself, the AR part of it, extensions. This is where the managers live. Some args items for the args that we pass through. Configuration awareness, because we're using semantics, and specifically awareness semantics, awareness.semantics. So once you've got all those in, this should, when we go back to Unity, not have any errors. So we'll just quickly check that Unity is happy. I haven't missed anything. Yep. And then the next thing we want to do is, as we've just written a script, we want to put it on something. So if you've watched my other tutorials, I quite often forget to do this step, which is actually add our script to an object that's in the hierarchy so that it would run. So drop that on the camera and then set this to the camera object here, because that's where we put the Semantic Segmentation Manager, because this needs a reference to it. Right, so now our script is hooked up so it can do something, but we haven't got any code telling it what to do. Before we go and write a bunch of code to grab the buffer and turn it into textures, we'll just add in some mocking so that we can just keep working in the editor rather than needing to go to device, because it takes a couple of minutes to do a device loop, whereas instant in the editor. I am just going to drop in the mockup scene. So if you just search for mockup, you will need to have imported the examples to get this scene. If you haven't pulled in the examples, you can either import them now, or you could go ahead and just make a cube or a few cubes to do the test with. I just find this is easier. This is our example scene, so I recommend just import examples and then drop this in. Is probably the easiest way to follow this tutorial. All right, so this scene here doesn't have anything amazing in it. It's just a table and some walls. Just check that you do have this mock world layer. If your scene does not have the mock world layer, add it. And then on the object itself, set this and go yes to all children. So you just want to make sure that everything that is in your mocking part of the hierarchy has that layer, because we remove this layer from the camera. So which is the next thing we'll do. We'll go to the camera and we'll look at the culling mask and we'll say we do not want to see the mock world. So if you see the preview down here, so you know whether it's working. If you see this in here, that's incorrect, because this is a preview of what it should look like on your device. And when we're running it on the phone, we don't want this little room to show up, so we remove it from this mask. But when we run it in the editor itself, that will be injected via this mocking layer here. So we've got our room, but that'll only ever show up in the editor now. So that's the first thing we should set up. Next, we're going to need to label a few objects in here so that the mocking scene can pretend that they are a semantic channel. So if you're in the real world, we can detect that the sky, things are sky or the ground, but in here we have to actually label the objects. So if you sort of click on one of these things, you can add a component layer in here. If you search for mock, you'll see this mock semantic label. And what this script does is it says which one of the channels that we support at the moment do you want this to be? So let's just say that's ground, and let's click this one and say that is something else. So we'll add the same script again. So mock semantic layer label, and then we'll say that can be sky. That'll work for me. Now that we've got those marked up, if we're using any of the semantics channels, it's going to think that is a sky channel and this is a ground channel. Right. So the very next thing that we'll do is write some code to do something with that. So if I run this at the moment again, nothing's going to happen. It's just the same, other than there's that script there that we could query if we wanted to. So if we go back to our script, we're going to say catch the buffer. The args will provide us with an semantic buffer, and then we'll turn that into a texture. So the first thing we do is we say, hey, sending object, please give me the semantic buffer. So now we have everything stored here. Now the semantic buffer itself is an interesting object. It's essentially a bunch of masked integers. So you have a 32-bit object. Each bit represents a channel. So if you wanted to do a whole bunch of binary math in your shader, you could actually convert the whole thing to a big texture, pass it into the shader, and then do a bunch of bit operations in there. That would work. You could also do it on the CPU side if you really wanted to. But typically what you're going to say is, actually, I just want the texture for one of the particular channels. Like I want the sky. So in this case, I'm just going to say, hey, semantic buffer, what is the index for the sky channel? So this will just return a number that we can pass to the next function. And that function is the create or update texture. So in here we can say, please give me back a texture, put it in, into a texture 32 of the sky channel. So I need to create this object. Obviously, we need a texture 2D to store it in. So texture 2D, one of these, and we will store that there. So this function will ask the semantic buffer to give it back a texture of just this one channel, which is sky. So now we have a mask basically of the sky in that texture. The next thing we'll want to do is we'll just render this as an overlay the same way we did for the previous tutorial. So we'll make a material, we'll put a shader on that material. The shader will take in our texture and a transform, so that the reason it needs to transform is the semantic buffer, just like the depth buffer, is not the same size as your screen, and it's probably not even in the same orientation as your screen. So you may have your phone in portrait or landscape mode when you're moving it around. We need to pass in a transform so that we can actually convert the image to align to the screen and crop correctly. So anyway, add a material here. We'll add an on render. So just standard shader stuff. We're going to call our blit function in here and pass in our material with our shader and some settings. So the first thing we'll want to do is pass in that texture that we've just created. So our shader is going to need this semantic texture that we made. So this material set the texture. And it's going to need a transform. As I mentioned, the orientation and dimensions of the textures produced by the ML model are not necessarily aligned with your particular device. So this transform, which you basically say, hey, segmentation manager, get me the processing unit that you use, the thing that does all the math, can you give me your display transform? This is just a matrix, and we're going to use that to multiply it against the UVs in the shader so that it will sample that texture the right way around. Essentially, it does the rotation for you. And then the last thing, obviously, because this is on render, we need to blit something. So just standard Unity, we go from blit the source destination with our shader. So that is probably the end of the code that we need in here. So every time the buffer updates, we ask, is there any sky in it? If there is sky, please give me the mask of the sky, and then render our shader and pass in this mask. And what we do in the shader is we can apply an effect to that channel or just blat it over the top, whatever we'd like to do. Anyway, so that's that bit done. Let's go back to Unity and just check that, again, there's no errors, that I haven't missed any namespaces or anything. So hopefully this is all happy. Yep, so let's go back to our folder. I'll just close a few of these so I can find it. This one. We're going to need a material. So create a material. And we can just call this semantic. Semantic mat will do. There we go. Oh, I'll make it lowercase. Sorry, I've got a capital A in there. Yeah, semantic mat. And then we will need a shader that will pass to this material. So create a shader. Doesn't matter what kind it is, because as I said, we'll delete everything that's in it again anyway. Semantic shader is good enough name for that. And connect the material to that new shader that we've just made, so that this material now knows to call this shader. And then while we're here, let's pass this shader into our script. So if we go back to the camera where our script was, this material needs to be set. So let's just, what was it? Semantic. With this white one here, semantics, yep, that's the one. Pass that in, and now we have our script set up. The next thing we'll need to do is write this shader that basically takes the texture and the transform and applies them. So we'll just get this set up here. Now we're basically going to delete everything in this shader, so it doesn't really, as I said, it didn't matter which one you picked. I'm really just going to keep the name. So I'll get rid of all of this. And I'm just going to plonk in a bunch of code and talk through it, because it saves you watching me slowly type a bunch of stuff. As all of this, there is a text version of this tutorial where you can pick over the code in more detail if you need to, if you can't type it fast enough, or indeed pause to scroll through this video. Right, so in here, we're passing in Unity's default main texture, so the scene itself. It is not what we want to pass in at all. So passing in the Unity, this is just named wrong. Sorry, on my notes, I've obviously reused a variable that I didn't need to use there. This should be semantic. Semantic texture, because that's what we're passing in here, and I'll just check that in my script I've probably not called it that. No, I have here, so that's fine. There we go. So just minor typo. Here we go. So just come back in and you go, basically, Unity will pass in this. We're going to pass in the semantics texture. As again, we're just going to blat something over the screen. We don't really care about culling or depth texture. It's a grid. It's basically a texture being splattered over the top in full screen mode. We need a vertex and a fragment shader. The vertex we're going to need to do to the UV conversions. standard input to the shader, standard output to the shader, plus this one extra UV where we're saying, hey, we're going to take the normal UVs and convert them using that transform that we pass in to coordinates that we can use to sample the rotated and different aspect ratio texture. Our matrix 4x4 that we pass in, and then here is our vertex shader where the first bit of magic happens. So this is just a normal standard vertex shader, pass through some stuff. But here is the multiplier I was talking about before. The transform that we pass in, the original UVs, we expand them to a float 4 so that we can do this multiplication. And what we want to get back is an XYZ value. So we store that in here. So now we have rotated coordinate space correctly. Then we go into our frag shader, so just here our samplers, so get the actual Unity texture, get the semantics texture that we're passing in. We can sample the main texture as normal with the normal UVs, but for the semantics texture, we need to do one little bit more math here, which is take the converted value and divide it by its z distance to normalize it out so that we get correctly spaced UV coordinates in the 2D space. So that gives you your 2D conversion. This is exactly the same as what we did in the depth example. So this line and this line are just standard things to remember to do, which will take your texture, which is, again, the wrong aspect ratio, probably slightly larger than your screen and rotated 90 degrees, to give you some sampling coordinates that will be able to pick that point from that texture and return it in the space that you're trying to draw. So now we sample this texture using our converted UV and we get the correct position back. This line here, all I'm doing is I'm adding the two together. So essentially this is just going to blat white over the top of the texture wherever there is sky. So the way we marked up our scene, we said that the back wall was sky, which means that that should be white when we run this. So that's the full shader. Let's go back to Unity. Hopefully there's no errors when we run it. Hit go. And here you go. Yep. White texture where the sky is marked. Now, just to test that this is working, we can click another surface like this wall over here, and we can add the mock semantic label to that as well. And we just say sky because that's what our shader is looking for. And now this one should also be white, which it is. So you got white there and you've got white there, which is great. And if I actually turn this off on that wall because I just don't need it there, so I will just remove this component. If I set the script to say look for ground instead of sky, it would make this bit white, which we can do. That's very quickly because as we are working in the mocking system, changes like this are very quick to do. So if I go back to my semantics texture here, it was sky that I asked for. But if I say ground, and if you remember, we clicked the, we put this, sorry, it's compiling, give it a second. This is ground. So if I run this, now the floor should be highlighted white. And there you go. So in the editor, what we've now done is we've said semantic system, give me a texture mask for any of the things that are marked up with whichever channel we're looking for so that we can put an effect on them. What I'll do next, just quickly, is put an effect on it. I'll quickly show you a small shader that will just put some stripy lines here. It's a couple of lines of code, updates to the shader itself, and just to give you an idea of how easy it is to do things like this. So I'm just going to replace the frag shader. So we go back to our code. And instead of in here saying all we're doing is adding these two objects, I'm just going to change this function to basically say, hey, I want to get the semantics channel and color it a little bit before I add it in. So in here, again, this is very, very simple stuff. I'm just saying take that color that got returned, I'm just going to fiddle with it. So instead of it just being plain white, I've got a sine curve here based on the UV where you are, and it'll just make it a bit of a grid and put some alphaing in it so you can see through it. And then instead of just adding the two things together, we will interpolate them so we get a neat blend across them, and don't need two returns. So what we've done here is we said, give me back the semantic texture, fiddle with it a little bit so it's colored. Also, add some alphaing to it so that you can see through it a little bit, and then blend wherever that is. So the main texture to the semantics color based on its alpha. So it's going to, where there is sky, it'll blend it nicely over the top. Now, if I go back to the scene and I run this, I should just see some stripy lines. And there you go. So stripy lines drawn on the ground in this case, because I changed it to be ground, and that is basically working now. All that's left to do is run this on the phone. Now, there's a small bug that I have to work around for this tutorial, because I'm recording it slightly before we have our proper release candidate. The naming convention here should be lowercase, but in the editor at the moment, it had to be uppercase for it to work. By the time you're using this, it will be completely fine. So I'm just going to cheekily change that to lowercase at ground. It should be lowercase in all the examples that you run into moving forward. And now I'll just build this and it should work perfectly on the phone. Okay, so that's now launched on my phone. Here it is running, and yeah, as you can see, it's put the stripy effect all over the ground, which is what we wanted. And that's the end of the tutorial. You're now able to get the semantic texture back for the layer that you want, pass it to your shader, and do whatever kind of effect you would like. Whatever you can think of, for whatever kind of world transform you feel like doing. Hopefully you enjoyed this tutorial and have fun playing with the ARDK.